Imagine something spinning not once per day, or even once per second, but 700 times every single second. These incredible objects actually exist in our universe. They're called neutron stars, and they hold the title for the fastest spinning things we've ever discovered. When a star much larger than our Sun runs out of fuel, it can't support its own immense weight and collapses. This triggers a cataclysmic explosion known as a supernova, one of the most violent events in the cosmos. While the outer layers of the star are blasted into space, the core implodes with unbelievable force. The pressure is so intense that it crushes the very building blocks of matter. Protons and electrons are squeezed together so tightly that they merge, forming neutrons. What's left behind is this tiny, ultra-dense object, a neutron star. Imagine a star with more mass than our entire Sun, but crammed into a ball just the size of a city, maybe 20 kilometers across. The density is staggering. A single teaspoon of neutron star material would weigh billions of tons here on Earth. Now, why do they spin so mind-bogglingly fast? It all comes down to a fundamental principle in physics, the conservation of angular momentum. But when that massive core collapsed from being millions of kilometers wide down to just a few, all that rotational energy had to go somewhere. Think of an ice skater spinning on the ice. When her arms are outstretched, she spins slowly. But when she pulls her arms in close to her body, she suddenly spins much, much faster. The neutron star is doing the exact same thing, but on a cosmic scale. As its mass gets pulled inward toward the center, its rotation has to speed up dramatically to conserve that initial momentum. Physics demands it. The smaller it gets, the faster it spins. While most newborn neutron stars spin a few times per second, which is already incredibly fast, some take it to a whole other level. These are the champions of spin, the speed record holders, known as millisecond pulsars. The fastest one ever found, a neutron star named PSRJ 1748-2446 AD, rotates an astonishing 716 times per second. To put that into perspective, a point on its equator is moving at over 20% the speed of light. That's more than 70,000 kilometers per second. It's so fast, it's almost pushing the very limits of what physics will allow. So, how do we even see these things? Neutron stars are tiny and don't produce their own light in the way a normal star does. But many of them have a secret weapon, incredibly powerful magnetic fields. These fields are trillions of times stronger than Earth's. As the neutron star spins, this magnetic field acts like a cosmic generator, creating powerful beams of radiation that shoot out from its magnetic poles. Now, if the neutron star is oriented just right, these beams sweep across space like the beam from a lighthouse. If one of those beams happens to sweep past Earth, our radio telescopes will detect a regular pulse of energy. This is why these spinning neutron stars are also called pulsars. For the fastest ones, we detect hundreds of these pulses every single second, ticking with a precision that rivals even our best atomic clocks. They are nature's most reliable timekeepers. What would it be like to get close to one of these cosmic wonders? In a word, deadly. Let's start with gravity. A neutron star's gravitational pull is billions of times stronger than Earth's. If you stood on its surface, you would be instantly crushed into a thin layer of atoms. But you wouldn't even make it that far. The magnetic field is so powerful it would literally tear the atoms in your body apart. And then there's the radiation. The intense beams of energy would fry any spacecraft and any life instantly, even from a distance. A neutron star's immense gravity and energy can warp and disrupt entire solar systems, making them one of the most dangerous neighborhoods in the galaxy. So, if they're so dangerous, why do scientists love them so much? Because neutron stars are the ultimate natural physics laboratories. They allow us to study conditions that are impossible to create here on Earth. They help us understand the nature of matter at densities far beyond anything we know, where the rules of quantum mechanics take over in strange and wonderful ways. By studying the precise timing of their pulses, we can test the limits of physics and explore the fundamental forces of the universe. This brings up a fascinating question. Could they spin even faster? Is there a cosmic speed limit? The answer is yes. If a neutron star were to spin too quickly, the centrifugal force at its equator would become stronger than its own immense gravity. It would literally start to fly apart, unable to hold itself together. The current record holders, spinning over 700 times per second, are believed to be very, very close to this theoretical limit. Any faster, and physics simply says no. The star would tear itself to pieces. So let's take a final look at these incredible objects. They are tiny, some of the smallest stars in the universe. They are unbelievably dense, containing more mass than our sun in the space of a city. And they are unimaginably fast, spinning hundreds of times every second, right on the edge of self-destruction, yet remaining perfectly stable for millions of years. Neutron stars are a stunning reminder that the universe operates at extremes far beyond our everyday experience. They are the fastest, densest, most precise cosmic clocks ever made, born from the fiery death of a star. Thanks for joining me on this journey to the edge of physics. If you enjoyed this cosmic deep dive, don't forget to like, subscribe, and hit that notification bell for more explorations into the wonders of our universe. See you next time.